Hello, Emily.
Hello,
How are you today?
I'm good. I'm very tired again. Every day
Oh,
I'm so tired.
especially on a Friday after
Yeah.
a long week. Okay, I'm just thinking for today. Is that okay if we are going to spend a bit of a time on using the CAS because you've got a new CAS? I heard that from last week. So
Yes, I do.
yeah, so I can share with you some of the tips that I have in
Yep,
terms of
that's
how
good.
we can use the CAS more effectively. Right. So if you have the cast with you, please have it ready.
Oh, I don't think I have the cast with me, but I think I can video record this. Is that okay?
Yeah, sure, sure.
How do I do that?
So what
Do
we
I
can
just,
do, or what we can do is if you want, you can video record this. I've also have this recorded. I can share the lesson with you after that.
oh, that would be good. Thank you.
Share- Yep, I can share the recording as well. Yeah, so I've got an online like a emulator, like a software version of the CAS that I think it looks like exactly the same or more or less, which is
Yeah.
CAS. If we go to the main screen, so we've got some advanced function which grayed out at the moment because I haven't subscribed to it. But later on, if we need, we can subscribe to that. Yeah, so it's not very expensive. So yeah, if
Hello.
whenever I do that, I just I pay. It's okay. It's out of my pockets. That's all right. Only like $3 per month. But don't worry. I don't think we're going to need that today. So
I have learned how to put my name
mhm,
onto the cast.
yeah,
And I think it's the standard and the decimal form when you like press the keyboard thing. But
mhm.
that's it. That's all I
That's it,
know.
right? That's all. Okay. So let's go to. Are you able to see my screen at the moment?
Yeah.
Yep. All right. So if you can see that, I've got this one like a reference. We can go through that first before we look at some hands-on exercise. So always when you started the test, this is the main screen. So if you press on that button, that will bring you to the main menu. So the main menu is got like different options like statistics, main calculator, graph tools, and the picture plots and all that. But the main one we are going to need most of the time is the first one. That's why they've got a much larger button compared with the rest. The next one, the thing you're going to need that will be the graph and table. This is where you want to use the CAS to help you to do some a bit of a graphing of the formula. So this will,
Yeah.
yeah, that will bring you to the main calculator. So there are some physical buttons. So some basic operations buttons are on the physical keypad. So you got the so plus minus
Yeah, that stuff. Yeah.
multiplication, and that exe that stands for execute. That means
Oh.
it's like equal sign. It's like when the after
Oh
you
yeah.
write down the
What
equation.
about
Mm.
the button next to it, the EXP?
The exp is the expression button. So if I go to here, go to the exp, so it's going to, I think it's more like an exponential actually. If you go to 10 e2, what's gonna get? It's like 10 times 10 to the power of 2. So,
Oh, okay.
so if you one exponential 5, that's equivalent to 10 to the power of 5. So it's yeah, I'm not sure why they have a dedicated physical button of that. It's not a very
Yeah.
commonly used button. Yep. So exe is the same as like equal button on any other scientific calculator. There's a one very useful button as well. It's like a backspace. When you type something wrong, you can use the backspace to go back. Where the keyboard buttons will bring up like a software.
Oh
Uh,
yes, I know the keyboard button.
yeah, so it will bring
That's
up.
when we can like
Hmm,
I think press like the square roots and that stuff. But yeah.
yeah, yeah, that's very useful because it brings up like a software button where you can select math one, math two,
Yeah.
and three, trigonometry, variable, and other like ABC, Greek symbol, and other symbols. Yep. So this is the keyboard you are going to need if you ever need to look at some other more advanced function. All right, so we'll come back to that a bit later. And that's what else do we need to know? Yep, got the keyboard here. You see with the fractions. The fractions, it can be obtained, can be achieved by doing a shift divide. So what that means is like, let me just clear the screen first. Oops, it crashed. And let's go back to it. If I need to do a shift divide,
Yeah.
you see there's like a fraction form. So 9.
Oh, so it's like a little shortcut.
Yeah, like a shortcut to bring out the fraction, or if you want that to be 9x divided by 2, you can do that as well. Yeah, otherwise you might need to do it like this, 9 divided by 2, but then it's not going to give you like a fraction, right? So if you want to do that as a fraction, do the shift divide, and you can do it multiple times to have a fraction on another fraction. Yeah, if you got it wrong, just press the backspace button to delete that.
Oh, okay.
Yep. And also, I think if you press the up button, you can actually scroll back to the previous expression and you can modify it. Like, for example, if I want to delete that, delete the X and press enter again, I think that will correct that for you. So you can just go back to maybe the other one. You can just say 50. So it's like 10 to the 50. Yep, so you can always go back and make any changes required by doing that.
So it's kind of like a keyboard type of.
Yeah, it is, because like if you have, if I put like 1 plus 5, and that's equals to 1 plus 5, it's not going to give you the value of 6 until you ask. I think you need to evaluate by putting a shift. No, not that one. Let's see. Let's do it again. And the 1 plus 5 will give you 1 plus 5. The reason for that, I need to put this one like in the algebra standard. Yep.
Yeah.
That will do. Yep, that's it. That will give you the value of that. But then I can actually put a answer. So the answer is like shift enter. So shift execute. The ANS stands for answer. That means I want to take the value of the previous answer. So in this case, this has the value of 6. And I press like 6 times 2. That equals to 12.
Oh, so it just automatically, you don't have to type the whole thing again.
Yeah. Yeah. So if I want to use 12 again, so I just put shift answer and plus 1. That will give me 13. But if I go back a few steps, if I change that value to, let's say, if I want to plus 1 again, so that will become 7. And that will change all the subsequent answers as well, because like 7 times 2 is 14. 14 plus 1 is 15. Or if I want to change this back to 6, I can do that. So you see one step I need to make, and I don't need to redo all the subsequent calculation. So I think that's one of the advantage of this calculator. To save you a bit of a time. You know, if you got this wrong, you don't need to redo the rest of it.
Yeah.
Yep. Okay, what else? We've covered that already. And then we have the square root, the power of, and the x root of something. Yep. So for this part, what we can do is, if we bring up the virtual keyboard, yep, that's the virtual keyboard. Under math 1, the tab math 1, you have the square root. So this one is the square root function. So if I click on it, I think will give me the square root. I enter the number, let's say square root of 49. And enter, I've got 7. So that's good. And power, I can do like 10 to the power of, so I need to go back to here, 10 to the power of 5. Enter. I have 1 followed by 5, 0. The other one is the nth root. So the nth root is this one. For example, the cube root of 27 equals to 3. So you see all the basics arithmetics are included here. You've got the square root, you've got the power, you've got the exponential, you've got the natural logarithm, you've got the log based on any base, you have the nth root. That
Oh, what's that one? Yeah, what's that
this
one?
one? Yeah, all right, let's delete that. You mean
The
this one?
one? No, no, the next one.
The next one, it's the modulus. That one?
Yes.
Yes, that's the modulus. That means if I have the modulus of 5, I get a 5. But instead of a 5, if I have the modulus of -5, I will be getting a 5 as well. So which means if it's a positive number, I get the positive number of the same value. But if I get the negative number, they will get rid of the negative for you. So the modulus is taking just the positive value of that number. Yep. Is that all right?
That is all right.
To move on, yep, you know what the x square is, right? So if
Yes.
I put in 5 and then square, that's a very quick way to do. And that one is the reciprocal, like I could do 5 to the power of -1. That's like 1/5. 1/5, yep, 0.25. And we
Oh,
have
isn't that like surds and stuff?
yeah. So that one is the reciprocal. But if you want that to be 1/5 in decimal, I think we need to change that to decimal. You see, you can toggle that, change that by standard, that will give you the exact value. If you put into decimal, if you enter that again, I think that will give you 0.2. Yeah, 1/5, 0.2. Yep, so that is the decimal standard. To DMS, that's the degree, minute, second. We don't, yeah, we'll cover that later on. We don't
Yeah.
worry about that for now. Yeah, this one is an interesting one. It's what we call simultaneous equation. So simultaneous equation is like where you can press in a variable. If I have x plus 1 equals to, maybe I'll just do 2 variable, x plus y equals to 10. And then I have the second equation is, let's say I have 2 x plus 1 equals to 11. And then in here, I just need to put in the variable I'm looking for. I would like to solve. I put in x comma y. It will solve that for you. The simultaneous equation, like they found that the only solution of that is when x equals to 5 and y equals to 5. So this is really, really powerful stuff.
So basically, you can just like use the calculator.
Yeah.
You don't even have to use your brain. You just need to know how to use the calculator.
Correct. Once you've got the calculator, you see, oh, this is so quick and easy to do it. But later on in BC, there are like 2 exams. One is without the CAS, technology free. So which means you still need to be able to do that without the calculator. And they will have the second exam. The exam 2 is with the CAS calculator. But then the second exam is going to be much harder because they expect you to do a lot more as you have a calculator to assist you. Yeah.
Oh, okay.
But don't worry, I think we'll work on learn how to do both ways using the CAS and without using the CAS. Yeah, for this simultaneous equation, if you press twice, you can actually solve a system of 3 simultaneous equation. If you press
But
one
then
more,
if you press one more time, you get 4.
you get 4. Yep, 5, 6. So it's really, really powerful to do that, right? So imagine if you need to solve a simultaneous equation of 5 equations, 5 unknowns. Manually, it will take a long time, but the CAS, I think, will do it for you very quickly. Yep, so the next one is just like a curly bracket and just a normal bracket. Yeah.
What are the difference? Like, is there a meaning?
Yeah, I think so. The curly bracket is the one that's like a higher level. So you usually you put in the normal bracket and you put the curly bracket outside. So it's like this one. Let's say like 1 plus x and multiplied by another 2 plus y. And then you put that outside. So which means instead of doing that, we put that one, and then you put x plus 1 followed by y plus 6 and close bracket, things like that. Oops, that should be another one there. So like that, yep, there you go, x plus 2. Okay, so another bracket, it's just multiple level of brackets. Yeah, I don't use this one much. I mainly use the normal one because that is the one that we use a lot.
Yeah.
Yep, the next function sets are sine, cosine, tangent. And
Oh, that's pretty simple.
yes, we did that quite a lot. And the next button is the degree.
Oh, there's a degree button?
90 degree, yeah, 90 degree. So what that means is if I want to do like sine 90 degree.
Oh yeah.
Yeah,
Oh yeah.
you can do it. So that equals to 1. But you may
But do you not have to close the bracket?
no, it's smart enough to know the bracket is closed without
Okay.
anything. Yeah. The only reason why you want to use the degree is when you set the mode to radian or gradient. If you use degree like this one, it's automatically, any number is automatically under degree. But
Okay.
let's say if I have that set to radian, I put a 90 degree, that will definitely, you're explicitly saying this is like this number is degree. Where the next one is in radian. So radian is like, you use something like pi to represent that, like pi, that is 180 degree. Therefore, you have 0, sine 180 equal to 0. So these are the two that explicitly saying in what unit the angle will be, regardless of the mode. But if you set the mode to degree, by default, it's always degree. Yeah, I think that one is a back button.
Oh, there's two back buttons.
Yeah, there's one physical and one virtual. This one is a copy, and that one
so
is
how do you do that?
Yep. So if you want to scroll up, that is already highlighted. You press that as a copy, and you put it here. You put a paste.
Oh, okay.
And put paste many times.
That's pretty good. That's a pretty good one.
Okay, that's a very good one. Yep. Yeah. So I'll just need to clean this one up. The next button is answer. So ANS stands for answer. It's the same as Shift Execute. And that one is the same as execute. So you've got the virtual button. You can press that with your stylus, that pointer, or you can do the physical button. Totally up to you. I think they have that just in case if something, sometimes during the exam, if this button is stuck, you still have a backup key to use that.
Oh, that's good.
Okay, so that is the math tab number 1. If we go to math tab number 2, you've got the line. What is the line exactly? I don't really use that much, so don't worry. We don't yet per our scope. The next one is the fraction, followed by the square root.
Oh, it's kind of similar.
Yeah, it is the same as that one. Yeah, so some of that I'll repeat, so don't need to say that one more time. So what about, okay, then we do have some gray out button. For example, the I button is the complex number, which you will see that when you get to year 11. That one is the infinity. That means it's a very, very large number. Yeah, we have some calculus gray out. Don't worry, we'll cover that later on in BCE. We've got the matrix. We haven't really worked on the matrix yet, isn't it? So, yep, again, we've got the sine, cosine, tangent. We've got the theta for the angle. Yep. What else? The next one I think we should really learn is the solve button. So under tab number 3, you have the solve. And that one is the best friend in terms of the algebra, because let's say if I have 2x plus 5 equals to 10, And then it will solve it for you. X equals to 2.5.
That's so good.
That's super cool, isn't it? Yes.
That's
Apart from that, let's see. Yeah, inequality as well. We can do inequality. I think it will solve for you. So instead of equal sign, if I put like less than, you see, it will solve it for you as well as an inequality. If we say is negative 10, it will solve it less than negative 7.5. Or if I replace that with greater than or equal to, it will do that for you as well. What else? This one, if I replace that with not equal,
yeah.
yeah,
And then it'll just solve it for you.
yeah, it will
So
solve
is
it for you.
so this calculator is just a cheating device.
Oh, okay, that's a that's a interesting way of saying that. Yes, it more or less is a device that, but to your advantage, you do need to know how to use it. You do need to know how to use that effectively as well, in a very efficient manner. Because like you, you've got the same CAS calculator with anyone else, so you want to be like to be in the front in terms of able to use that to your advantage.
Yeah.
Mm. Okay, so for the trigonometry, you've got the inverse sine, inverse cosine,
Oh,
inverse
okay.
tangent as well. You've got the hyperbolic sine, hyperbolic cosine, but we won't cover that. It's out of the scope, even for year 12. Yep, in the inverse hyperbolic sine, don't worry. That's not until going to university or if you study engineering later on. So you may want to keep the CAS calculator to your university years as well. You will find it useful no matter what course you're going to do. If it's a scientific subject or engineering, you're going to need that. Yeah, variable, just a way where you can define something, right? If I say if A equals to 7, so they set A equals to 7. That means A is a constant, always equal to 7. And when I do like 2A, it will be 2A. But then I think if they are going to evaluate that for you at all, so if I change that, we might need to do a define. So if I want to define, maybe put it here, does it going to give you? No, it's not going to give you the A value 7. So we may need to define that. Define a variable or no, or use a var. Financial calculator, advanced calculation. See, we've got that one. This not under there. Set action. And calculation, this command define. Oh, maybe here, define. If I define A equals to 7, invalid name, right? So they may not like that. Let's see. If I put something like a define and what else I can do? Define B equals to 7. No, it's not gonna like it. Don't worry, we'll do the function first before we do the variable. So the next thing is we can define a function. So define a function is going to be very useful. Let's say the function name is f and the variable is x. Then I'm going to put the expression in here. Let's say x plus 5 is my expression. And when I click OK, you see I've got a define. That means I'm asking the calculator to remember this function. Whenever you see the function of x, that equals to x plus 5. And the calculator responds and say, done. Already memorized that in the memory. And after that, if I put the function, if there's a button here, I can recall it. That maybe, I don't think it's the same as that function. So if, yeah, that one's okay. So f and the bracket, I put 10 in here. So the answer should be 15 because I'm just telling the calculator to use the function that I have defined with the x value equals to 10. So which means I can put in any value in here. I can do it again, put in any value like 90. It would be 95. So super useful because let's say if I define that to be something more complicated, if I do like maybe that's square and then plus 5, followed by sine 2x. Yep, like that. Remember already. And I can actually use that by calling the function again and put 10. It will give you the value. And without typing everything in here again. So you can actually evaluate the value by using the same function again and again. So lots of like reusability. Is that okay?
But then how do you like delete it just to like let them know that you don't need to use it anymore?
Okay, don't need the function anymore.
Yeah.
Yeah. All right. So what you can do, go to action, and this under. Let's see. There should be a list of function, or let's see what else we can do. The calculator is a bit different. Transformation. Nope. Define calculator command. I think that is the one. So if you go to clear all variables, see if that works. So are you sure you want to clear all variable? So I click yes already. So if I do that one more time, see if that only clear the variable or clear the function. Okay, so the function is still there. That should be under command and clear base set. No, pretty sure that's under here. Transformation, advanced, fraction, complex list, calculation. No, not that one. Not under here. Assist, no. Distribution, no. Financial, no. I think it's under here. One of it, yeah. Is it under display stacks? Let's see. Nope, that one. Maybe I'll look it up. I'll let you know next time. So
Yeah. Thank you.
yeah, no worries. Okay, so you've got the create the function and then able to solve the equation as well. Let's see what else we need to learn. Let me go to the list where I've got it here. We go to mesh method under here, under CAS, and we're using the Casio class pack. Yep, so we have learned about define the function already and able to solve it as well. So after you define the function, you can actually solve the function. That means in here, what we can do, if I have, are you registered? Do you provide? No, not yet. Let's define a function. So if I define a function, f of x equals to x plus 5. Yep, like a simple one, where I can solve the x plus 5. So I can solve function of x that's equals to 10. And enter. It will tell you that x equals 5. So that means you can use that in conjunction, like the solve and the define together. Yes. So once you define it in the calculator, you can actually use that many, many times. Okay, so what else we can learn about? Solving the equation. Yeah, we did that already. But solving it, there's a way where you can define a range as well, so that you can define like a condition to it. Let's say if I defined the function as a quadratic, x squared plus 5, or oh no, maybe just x squared plus 2x plus 1, okay, something like that. And you see, I solving it, I solve that quadratic, it's got two equations. It's got a positive and a negative number. But if I wanted to limit that to only a negative number, I can actually pipe that, like putting a condition. If I put a condition there where x has to be greater than 0, so it will just give you a single number. So the pipe, that vertical bar, that's a condition. It's a condition. If I put it like x has to be less than 0. So if I enter, that will give you the negative result. If I go back to the function, if I take something away, that will change as well. So
is there a function that when you have an answer and has a lot of decimals but you want to round it up to like the whole number, the first decimal, second decimal, is there a button for that, or you just have to do it yourself?
Yeah, you need to do it yourself, but there's a function where you can put it as in standard form, so like an exact value. So if you do that, it will give you the exact value. But the rounding part, I think this one, most likely we do it ourselves.
Oh, okay.
But I'm pretty sure it's smart enough to do like if you can specify to round to a certain digit. But yeah, I don't use that much because it's easier and quicker to do it ourselves. Okay, so we covered that already. Solving the equation, I think we covered the solving part already as well. We did the simultaneous equation as well. Let's maybe spend a bit of time to do the graphing part of it. I think you will like that because when we do the manual, the graphing tool. So the graphing tool is, I can actually, let's remove all that. And I want to plot, let's say a graph is quadratic. Let's say x to the power of 2. And I want to graph that. So I just click on the tick button and press enter. So see if that's plot for me. So that, need to click on this, graphing. There you go. So you see, that's actually plot the graph for you already. And you can move around because it's touch screen.
Using the stylus.
Yeah, using the stylus, you can move it around. And if I change that and say plus, let's do something a bit more sophisticated. This is sine x. And then I graph that as well. See what that will look like. Okay, so click on that. There you go. That looks about the same. Why is that? You can click on that and the graphing tool. Maybe just change that a little bit to sine x. See if that works. There you go. So you need to, that's why, because before was the scale, we need to zoom in. So you zoom in.
You can zoom in. So you press.
Yep, you can zoom in and out. Yep, you can zoom in and out, and there you go. And zoom out, you'll get that, or do auto, or you can do auto. It'll give you a good looking sine graph. And I press plus x squared. I think that should work this time. Do the x squared and get rid of the keyboard. Plot again. There you go. So I do zoom auto or zoom out, zoom out, zoom out. Yep, that's like sine x plus x squared. So I think that's kind of like if you go up, 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 it's superseded by the x squared. No, don't worry. That's how it looks like. But if you get rid of that, plus cosine or plus tangent, tan x. See what that looks like. Press again. There you go. Something funny looking.
It's very funny looking.
Yep. I think that's right because tan x is kind of like that, and then plus sine x. Yep. So you see, you can actually plot something as an experiment to see how things look like when you do that. Yep, that's a tangent graph. Yep, that looks good. Okay. So it's good when you have the calculator or without the decimals, like the computer. If you have the computer using the decimals, I think that's much better. But in this exam situation, the only way where you can plot the graph is the calculator. Okay, so that's all I can think of. And there's something I need to work out, for example, how we can delete the function. And once I find out, I'll let you know next week. All right, any questions about the CAS before we jump to today's topic?
I don't really have any questions, but like how to delete functions and like that type of stuff.
Yep. Okay. So maybe once you've got the calculator with you, we can spend a bit of time doing some example questions together. But since you don't have one, we can work on the next chapter today. So the next chapter today is on indexes, and it's a more advanced level of indexes. So let's see. All right. Let's get rid of the keyboard and I can write on it now. So for indexes, the lesson for today, let's focus a bit on that. It's a very basic thing. The basic thing is like when we have the base and when we have the power, like a to the power of n times a to the power of m. Do you still remember what that's equals to?
I think that's like n plus m, like that's on the top.
Right. N plus m. Yep, that's law number one of the index. If I have the opposite, what happens if I have a to the n divided by a to the m?
Oh, it's minus.
Minus, yep.
Oh no, or is it times? I don't know which one.
A to the n minus m is the opposite. Where? Because if that's multiplied, that's become a plus. That is a division, then it's a minus. Yeah, and that can be also written as a to the n divided by a to the m. Yeah.
That makes sense.
Okay, next one, the power of power. If I have a to the n to the m, what does that equal to?
Oh no, this is the times.
This is the times, yes, because it's the power of power. Very good. Yep. And if I have the different base, let's say the a to the n divided by b to the n, how can I simplify this?
Oh, you just minus the ends.
It's a minus n, but we have different base though. If we have different base, we cannot minus. But
so you gotta like divide.
Yeah, we can just do a divided by b, both to the power of n. Yeah. We've got another one, a to the negative n. What does that equal to?
A to negative. So when you go on the other side, I think you have to like make it like a positive.
The positive, so it's like 1 over a to the n. That's the reciprocal.
I remember this one.
Yes, and another one. If I got a to the a over b to the power of negative n, what can I write this as?
Oh, is this the one where you like flip the b and the a?
Yes, very good. Yep, good memory. So, and then this becomes positive n. Yep. All right, let's see anything else we've got for that. Okay, what about fraction then? A to the n over m.
Oh, I don't think I remember this one.
Yep, that's a more advanced one.
Maybe.
Let me give you another one to bring your memory back to that. If I've got a square root of a, that's the same as a to the half.
Yes.
So which means if anything like n,
So you go put it into a square root.
yeah, put it into a square root, and is the m root of a, where the n can put anywhere. Like we can put it in here, or we can put it outside, as the multiplication is commutative. The order does not matter. Yep.
Yes.
So yep, that's the generic form, but easily the entry level is like the root a is a to the half. So fractions for the power. Okay, so I think that's pretty much ready for the first question. So let's do that. I'll send you the link, and if you want to work on that, that would be great. Okay, send you the link. If you want to open that up, and I'll just give you the first question. So if you can simplify the following, 2x to the 5, y to the 4 divided by 10, x squared, y to the 3.
Okay. So this equals to 1. Oh, so you don't even need to put the 1. No.
Almost. Yep. 5. That's it. Very good. Okay, next one. If I've got negative 4a squared b to the 5 to the power of 0.
Oh, I forgot the power of 0. Hold on.
Yes, to the power of 0. What is that? If anything to the 0, the a to the 0, that's equals to 1.
Anything equals to 1.
Anything
So
except
that
for 0,
whole
though.
thing.
A cannot be equal to 0.
So that equals 0.
That equals to 1. The anything to the 0, that equals to 1.
So 1 times 1 times 1.
Yep, but you've got
So,
times negative 4.
so negative 4 is the answer.
Yes. Very
That
good.
was very, very confusing.
Yep.
But
Next
I
one.
think I remember.
Yes. No, it's good. But this one back, yep. 2b to the 3 to the 0.
Okay. This here. It's like basically 1. No, this will turn into 1. I think so.
And so, yep. So
Okay.
this one is like power of power, the whole thing to the 0. So that means the whole thing is like 1,
Oh, so not even including the 2.
not including, yeah, because this can be rewritten as 2 to the 0 times b to the 3 times 0. If you're going to split that into each element inside the bracket.
Okay, that makes sense.
Yep, enough. Yep. Let's do next question. It's 2x to the 3 over y to the 4 to the power 4.
Okay. Okay, dokie. think I remember this. Okay. So this time that. This time that. And this time that.
Yep.
Okay. So 2 times 4. Okay.
But that one is more like 2 to the power of 4, and then times 4, and times 4.
Okay. Oh, yeah. Similar to that.
Mm-hmm. 2 to the 4, which is 16. Yep, x to the 12, y to the 16. Awesome. Right. Okay, and let's do this one. We want to solve 7 to the x times 7 to the 1 plus 2x divided by 7 to the x squared equals to, this is a big number, 16807.
Okay. 1 plus 2x. That is very confusing. But then you already put the answer. Hello?
Hello, yes. Yep.
I think I think I see like the answer.
Yep, but we need to find x. So what does x equal to?
Oh, okay.
Yep, so solve, kind of like solve x.
So first you gotta bring these numbers over that side.
Yep, you can try that. Or
So
you can try simplify this as much as possible first.
Okay.
Let's say multiply.
Oh, sorry. 2x.
2x.
And then x times that, so there's like 4, 7, 7, 49.
If you multiply that, the same base, you cannot combine that into 49.
Oh.
So what we can do, we have 7x multiplied by 7, and it's a 1 plus 2x. So that means like multiply by 7 to the 1 and 7 to the 2x. And where you have divided by 7 power of power, it's like 7 to the 2x. That's equals to 16807. And they are the same, so the 2 can cross out. That means 7 to the x times 7 equals to that. So bring the 7 to the other side. 16807 divided by 7. And that's equals to 2401. So 7 to the x equals to 2401. So we need to find out like 7 times 7 times 7 times how many 7 equals to 2401. So that's
2401.
Yeah. So I think it's a 7 2401 is like 49 times 49 is 2401. So that means it's 7 to the 4 equals to 2401. That means x equals to 4. Okay, makes sense?
Yes.
Yeah, that's a difficult one. So it's good that if you understand that. This one, 2 to the 2x minus 5 times 2x equals to -4. All right, so give it another shot. If it's too difficult, let me know. I'll walk you through the solution to explain to you.
That was okay. Okie dokie. 2x1. So we would expand this first. 2x. Wait, how do I expand? 5, 10.
How to expand? Let me give you one hint. One of the big hints for this one is let a equals to 2 to the x.
Okay. Let a equals 2x. So I substitute a.
Yep.
So 10a. Or is that different?
Different. So it will be, if it's a 2 to the x equals to a, that means like 2 to the 2x equals to a square, because that is the same as 2 to the x square. So it's a square, and that is a. So you have a square minus 5a equals to -4. Okay, so when you see that, what does that look like to you? We need to like find a.
Well, first you gotta like combine the a's together.
Yeah, so this is like a quadratic. Yeah, if I took a squared minus 5a plus 4 equals to 0, that's a quadratic where you can be factorized into two numbers. Where the,
Yes.
yep, the two numbers, when they multiply, that equals to 4. If
And
add,
plus.
equals to -5.
So -4 plus 1 times 1. Wait, what? -1
-1
times
times,
-4.
good
Yeah,
one. Yes. So that's
that
minus
makes
1
sense.
to -4. Yep. That means a equals to 1 and 4. Now we use the, because we let a equals to 2 to the x, that means 2 to the x equals to 1 and 2 to the x equals to 4. So 2 to the what number equals to 1 and 2 to the what number equals to 4.
So we only have those two left.
So this one is like 2 to the 0 equals to 1. So x equals to 0 and 2 square equals to 4. So x equals to 2. Using that number and that number, that number and that number.
Well, that's very cool.
Okay. Right.
Very hard
Very
for my
hard.
brain.
Okay, but once yeah, if you can see that, you know how to solve it next time. All right, and we can do it. Another one, try this. 4 divided by a to the negative 3. So what does that simplified to?
Okay, I remember this one. You gotta flip this one.
Yep.
Okay, so is this one the one where you put the 4 at the bottom? Or is it the one where you like create the square root?
So if you have anything like 1 to the a negative n, you can flip that to the top. So that's equals to a to the n.
Okay. Oh wait, I'm just running the same thing. Wait, what? What about the 4? Where does the 4 go?
This is 4. The 4 can leave it outside for 1 over negative 3. So that means it's like 4a cubed.
Oh, okay.
Yep.
Yeah, that makes sense. So the 4 is just outside. Yeah.
Yes,
that
4
makes
is
sense.
outside. Yep, yep. Because multiplied by that. What about this? 2m negative 4 n squared.
Oh no. Okay, I think is it this like this? Or
Almost,
maybe it's like completely different.
almost correct, but the 2 should go up because that is a just 2 multiplied by m to the negative 4 and multiplied by n squared. So the n squared goes there, the 2 goes there. Only the one with the negative index gets to the bottom. Yep, let's do another one. 2m cubed divided by n negative 2 to the negative 2.
Okay, okay. Oh, this one's like similar. So you switch it around.
Yep. Can switch it around. Yep.
So, oh, I know this one. I think you like keep it here, but you bring this one to the top.
Yes.
So now it's like that. But then what about this one?
When you bring to the top, it becomes positive and negative 2. That means bring everything back to the bottom.
Okay. But now we're gonna make the 2 positive.
Make the 2 positive and everything at the bottom. So positive.
So just 2. And then like that. Maybe not.
So the whole thing that gets distributed to the bottom. So it's like 1 over 2 to 3 m square square.
Okay.
So it's like 4m 6 and 4.
That makes sense. Yeah, I know what you mean by putting this one here.
Yeah. Okay, so I think I have worked out how to delete the function. So if we go back to the main screen, are you able to see the calculator?
Yeah.
Yeah.
I
Okay.
can see the
So go
calculator.
to go back to here. and navigate to setting. So there's one called setting, I think. Navigate to setting of variable manager. There should be one called variable manager under here. Oh, here, that's it. I forgot this is a button. So variable manager. And if you go to view library or not variable manager, where you can select the function to delete. So there's a two variable main or input. Yeah. Variable manager, view library folder. Nope, not here. Edit, rename, delete, close. It's not in here. So select the function that I want to delete and do I have the function? Maybe I don't. Let's do it one more time. So if I got the function here, f of x. Let's see if I input that keyboard function f of x. Okay, so the function is here. Default setup, view, Windows, variable manager. I'm pretty sure it's in here. So edit, create folder, or variable function. Interesting. It's not there. Search. If it's not there, advanced format, main default setup, keyboard. Oh, okay. So maybe I'll find out one more time and I'll show it to you next week. Not sure why something is not right. It used to be here. Okay, that's fine. I'll figure it out and I'll send you the email once I find out that. Okay.
Yeah.
All right. So I'll see you next week then. Take care.
Thank you.
Okay. Thank you. Bye, Amy.
Bye-bye.
Bye.